Hi guys, can you hear me?
Yeah, you are audible.
Yeah. Good evening.
And are you guys from the same team?
No.
No, sir, we are from different teams.
Okay. So do you all have a separate WhatsApp group to coordinate, or I'll just like let everyone come on their own?
We do have a group of leaders.
Oh no, I'm talking about individual teams because
Yes, we do have.
Good. Okay, it's 6:30, but the turnaround is quite less. Okay, we'll start in 5 minutes. We'll just let everyone join in. We only have around 13 people in, but the total number of students is around 39. Guys, can you check with your teammates if they're in lectures or do you have conflicting lectures? Like, are these sessions conflicting with some of your peers' lectures?
No, sir. I don't think. There are some lectures so late.
Okay, so we've got around 21 people in. We'll just start in a minute. Okay, before I forget, has everyone downloaded the software, Fusion 360?
Yes, sir.
Okay, great. So I'd say at least one member in each team have it right now, because when we'll be modeling the 3D models, there'll be at least someone who's practicing along. I'd recommend everyone practice along. Yeah, I'd recommend everyone practice along, but at least one of you should, try and learn the basics of it, because what we're actually planning from this track is that by the end of it, you could have a full solution to one of the problem statements, but along with that, you could also have a model which we could print it here in the lab. So we've got 3D printers here up in the lab running. So whatever your solution to the problem is, we'll try to develop a miniature prototype of it, or at least a prototype which you can carry around. Let's say you're developing something which is really huge or really bulky and you cannot carry around. We'll try to minimize it and print it so that you can take it out. Okay. Okay, so we only have around 23 people in. Guys, can you, like, team leaders, can you please check? We'll start at 6:40 sharp. But team leaders, can you please check with your respective members if they're in? Okay, so I think we'll just start. I just want to make sure members from at least one member from each team is present. So anyone from Technovi, could you just say that you're here? Technovi, anyone from Technovi?
Yes, sir. Yeah, we are here.
Okay, sure. Thank you. Team Desire. Team
Yes.
Desire.
Yes, sir.
Okay, yeah. Team V Bros.
Yes, sir.
Okay. Team Innovi5.
Yes, sir.
Yes, sir.
Team 3D Wizard?
Yes, sir.
Okay.
Yes,
Team
sir.
the Mind Brewers? The Mind Brewers? Anyone? Mind Brewers? Okay, I think they haven't joined. Okay, Team Reformers?
Yes, sir.
Okay. Team we4tech? Team
Yes,
we4tech?
sir.
Okay. Team Red X Stars?
Yes, sir.
Yes, sir.
And I think Team Me and We.
Yes, sir.
Okay, so is there any other team that I have missed out on? Okay, I think everyone's here. At least one member from each team is here. So we'll begin the session. It's you can keep your videos off, but whenever I ask questions, I want at least a few of you to answer, so that this is not a one-sided thing happening. So how many of you have had prior experience in 3D printing, like any softwares for 3D modeling back in your college days? Engineering, I think AutoCAD, SketchUp, Blender, all these. Anyone has used?
Yes, sir.
Okay, great. So have you all just been like modeling things or also printing? Like any prior experience with printing?
So never printed before, but I have done the designing part.
Okay, that's great. That's great. Okay, so before we go to the 3D modeling part, we'll just start with the technicalities of what 3D printing is, and we'll also look at some technical details of a 3D printer. Okay, so I'll just share my screen. Is it visible?
Yes, sir.
Yes, sir.
Okay. So yeah, the track name everyone here knows, it's 3D modeling and printing. So what exactly is 3D printing? You could say it's a form of additive manufacturing, and the reason I'm calling it additive manufacturing is it's because it's a layer by layer process. I'll show you a video wherein there's this printer printing a miniature version of the Eiffel Tower, and there you see that the printer prints layer by layer, and that is why it's called additive manufacturing. There is also something called a subtractive manufacturing. So if you've seen marble sculptures made, you see that there's either a CNC machine or there's some person with a chisel and a hammer removing bits and parts from a marble piece to form the sculpture. That is subtractive manufacturing, whereas 3D printing is additive manufacturing. Uh, the the real problem with 3D printing is that it's a very slow process, or it's a very time consuming process. So when we'll model, and when, if in case we can print something for y'all, we'll show you how the printing happens. And in the video also, I'll show you like that's been fast forwarded, but I'll tell you approximately how much time it takes to print a really small model also. This technology has been around since 1980s, but it was restricted because of certain patents, and it was only available to high-tech institutions who wanted to do prototyping, but they had to shell out huge amounts of money to get those machines. But recently most of the patents have started expiring, and that is why we've seen this boom in the hobby 3D printing market. You can see miniature 3D printers all around the world now, and everyone has access to prototyping using these machines. Okay, so what are the pros of 3D printing? One of the good things about 3D printing is if you know 3D modeling, you can print almost anything. Like applications today include building houses as well. And people have been, they've been trying to market this as something that can be used for Mars explorations or moon explorations, wherein people don't have to move to build or assemble anything. They can just send in machines which can print habitats for them. And this has been proven here on Earth. We've got machines, we've got 3D printer, concrete 3D printers, which can literally build houses for you in a matter of hours. The cost of printing individual parts is significantly less than the manufacturing process. So now let's suppose if you were to, let's suppose you were to build the dashboard for a car, the usual process is you get a mold, like you develop the mold, you'll design the mold, you'll assemble it, and then assemble a dashboard from it. This requires a lot of time, but let's suppose if you had a 3D printer which you could build the dashboard in parts, you could reduce the time it takes to try and test out different things. Okay, the next is it's best for prototyping, as we all know. We'll move to the next one. Okay, so the example of where all 3D printing is now being used. On the right, you can see the construction. It's actually a representation, a graphical representation, but there are case studies where people have actually built houses from this. And on the left, you have the application of 3D printing in the medical domain. 3D printing is now being used to develop artificial hearts using your own cells. So that is one application in the medical domain. You could design jewelry. You could, design your tooth implants using 3D printing. So there is no such field where 3D printing has not left its mark. Now that we've seen the pros, we can also look at what the cons of 3D printing are. It's actually time consuming because it requires multiple iterations. You cannot be sure if a certain prototype will work or not for you. So you have to keep on, iterating over multiple designs, over multiple models to finally come to your required specifications. And also, what can happen with hobby 3D printers is that it's not of industrial quality. Let's suppose if I were to design something here in the lab, because we've had the 3D printer for at least around 5 to 6 years, the quality of print has degraded over years. So if we were to, let's suppose, participate somewhere and we had to show a prototype, chances are that our printer would not be able to print at such a high level as other new 3D printers. Also, manufacturing process, what happens is you've got the manufacturing process has been perfected over decades, but 3D printing, because it's still kind of in the nascent stage and hasn't really picked off, the quality that you get is not really good. One of the pros that I missed out on was when I say that it's best for prototyping, 4 companies actually printed 0.5 million pieces of internal parts for its cars. So rather than having to design the complete manufacturing process for even testing or like developing new cars, what they do is they 3D print parts and then they'll test it out. Even though you might think that, okay, it might take more time, it is still comparatively faster to manufacturing processes. So, even big companies like Ford are using this in, let's suppose, like the dashboard example that I gave you, or also it could be for some, if they want to develop something for a braking mechanism, 3D printer is there to, print it out quickly and give them results rather than having to wait for weeks to get it from a manufacturing process. Okay, so now that we've just covered the gist of what 3D printing is, we'll just look at the terminologies which are associated with a 3D printer. So these are the 2 major filaments that are used in the industry. The first one being ABS and the second one being PLA. ABS is made out of fossil fuels. PLA is a biodegradable natural material. The major difference is ABS tends to be slightly harder, whereas PLA is slightly like it's less harder as compared to ABS. Also, the temperature range at which you need to heat so that it comes out of the machine even that is different. But yeah, I think the only major difference is the hardness. So it depends on what your application is. If you want like a semi-solid or like a bit of a structure which is not that rigid, you can go for PLA. If you're going for something which is like really hard, which needs to be really hard and rigid, you could go for ABS. These are the extruders. This is the extruder and the nozzle. So on the left is the extruder, and if you see the blue filament going in, that is the filament that passes into the extruder. And the extruder is the part where the filament is melted. And the nozzle is the part from where the filament comes out, which is then printed onto the bed. So this is a heated bed. It's self-explanatory. Like this is a bed on which the material gets stuck, and the model is built over this layer by layer. Okay, so we just look at the two major types of 3D printing. I'll just show you. Yeah, so this is okay. So this one is fused deposition modeling. This is the largest, like by proportion. This one is the most used method, or this 3D printer is the most used one. Fused deposition modeling. This is the layer by layer thing happening using the extruder and nozzle. We'll just look at this video. I guess this is visible, right, guys?
Yes, sir.
Yes, sir.
Yes, sir.
Yeah.
Yes, sir.
I'll just do this and I'll fast forward. This is like a really big video. So I think you can see that all of these things are being printed layer by layer, and that is where this is time consuming, but it's not as time consuming as a manufacturing process would be. So I'll just let this video run through.
Sir, I'm sorry to interrupt, but it's lagging a bit.
Oh, I think it's really fast. That is why. I've speeded up. Okay, I think you get the gist
Yes.
of what I was trying to say, right? I'll just skip, I think, to the last part wherein it's completing. Okay, so if you can see, this is the complete model that the 3D printer has printed. This can take anywhere between 10 to 48 hours to print, and that depends on the level of fineness you want in your model. Now, this could be like a one-day model, but you can even increase the fineness of the model to get smooth lines on your on the final project. So this is one method. The second one uses a laser and a resin to get your model out of it. So you see those flashes of light, those are lasers being hit on the resin surface. And when the laser hits the resin, it solidifies. Is this clear, guys? Or am I going too fast?
It's okay, sir. It's nice.
Yeah, so
Sir,
you've got, yeah.
can you tell what kind of substrate is used for printing in 3D modeling?
Substrate as in the material you're saying? PL, that's plastic. PLA and ABS, both of them are plastic, but they're derived from different sources. Okay, so you see here, every time the laser hits the resin, the structure emerges out of it, and you can print different models using this technique as well. Yeah, you can see this is much more finer than the FDM method. But one of the cons of this method is that the cost of printing per kg is really high in resin-based methods as compared to FDM. Like, it's almost 4 times of what you get in fused deposition. Masked stereolithography is similar to stereolithography, but there's just a mask, a different kind of a light filter mask which is placed so that it's not harmful for your eyes. It's just the addition of a mask. Apart from that, there is no difference in both the techniques. This is a stepper motor. So in FDM, if you've ever seen a 3D printer, you know that the extruder moves in 3 directions, X, Y, and Z. And these stepper motors are responsible for, those precise movements which happen. These stepper motors have a really high precision. You could get somewhere around 0.2 mm to even, let's suppose, 0.01 mm. So these machines are really responsible for those fine adjustments that are made. So you've got 3 stepper motors, one for the X-axis, one for the Y, and one for the Z-axis. Okay, so we're looking at slicer. Now, the slicer is a software based thing. So when you develop the model, you need to give it to your 3D printer. Now, your 3D printer will not understand the model directly. You will have to convert it into something called as a G code. So I'll go through what the G code is, and then we'll come to slicer associated terms. The G code is actually the machine level code that the 3D printer understands. So here, if you see, there are a lot of different settings like the fan speed setting, or the speed at which the nozzle should travel, the layer height. So how thick every layer should be, what amount of filament should the extruder give out. So that is the extrusion length, the XY coordinates, like at what point should the extruder be so that, it can print something. So this is the G code that is responsible for printing everything. And the slicer is something that converts your model into the G code. Now in slicer, in simple terms, I'll say that your slicer actually slices your model into thin layers. So let's suppose you've got a sphere, and your slicer will actually slice that sphere into multiple layers, and then for each layer it will generate the G code. So what all parameters will that have? The first one is layer height. Now, if you keep the layer height to less, the number of slices would increase, right? If let's suppose I keep the layer height to be 5 mm, a sphere might be completed in 20 slices. But if I reduce the layer height to, let's say, 2.5 mm, the number of slices increases. So that is the layer height. Then comes the shell thickness. Let's suppose you were designing a cube which is hollow from inside, and you have 3 mm as the thickness of your cube. So that shell thickness is what shell thickness here refers to. For different models, we'll have different shell thicknesses depending on how thick you want the inner walls of a model to be. Next is the bottom and top thickness. The same, like the first layer thickness and the last layer thickness. Fill density and pattern. Now, fill density is basically asking you how dense you want your model to be. Like it could be 100%, but this will take a lot of time to print. It could be 10%. Usually, what people use for prototyping is in the range of 10 to 20%, because it's enough for prototyping. It's faster compared to like a higher density fill value. And pattern here refers to different patterns in which the 3D printer will print the inside layers. So there's hexagon, there's triangle, and there's also circle sometimes. So you've got these 3 major patterns which are there. Print speed, it's self-explanatory. Like at what speed do you want to print it? If it's too fast, the filament might not stick at the bed. If it's too slow, it'll take a lot of time. And then you've got printing and heating bed temperature. Printing temperature is basically, as I said, ABS and PLA both have different temperature, both require different temperatures to melt. I think ABS is somewhere around 220 to 230 range, whereas PLA is at the lower side around 200 degrees Celsius. And the heating bed temperature is generally kept around 50 degrees Celsius. I'll tell you why we need to heat the bed. Yeah, so if you see here, these are some of the common issues, and I'll come back to why the heating bed, like the printing bed is heated. Now, if you see on the left-hand side, you can see that the edge is slightly raised. Now, this happens because the first layer has cooled fastly. It has cooled faster as compared to the above layers. And with 3D printing, the only way you can stick to layers is when they're hot. Like only if they're hot, they'll stick to each other. Otherwise, they won't. And if the bottom layer cools too quickly, it'll also raise, like you can see those raised edges. So when you heat the bed as well, like it's around 50 degrees Celsius, when you heat it, it makes sure that the bottom layer does not cool quickly. The next on the right, the image on the right, if you see, now this dog model here, this first one, it's got no supports. So basically supports are also used to avoid these upward the first layer curling upwards, because it adds one more layer. If you see here, this is an extra layer which is added. I hope it's visible, guys.
Yes, sir, it's visible.
Yes,
Yeah,
sir.
so this extra layer that is added, it prevents this warping which is happening over here, and it also makes sure that all the other layers stick and come out as per what your model is. That is an extra layer which is not there in your model, but the software will add it so that the warping does not happen, as well as your model comes out perfect. Now, even with these rafts, there is a problem. If you see the belly of the dog, it's all stringy. Even the head, I think it's not that clear, but I think with the belly, you can see there are these strings which are coming out. Now, this is because uh, the printer was printing in air. It had nothing below it to, rest it upon. So that is where supports come in picture. So supports are something like an extra structure that you add to your model to support something which is going to be printed in air. All right. So make sure that whenever you're modeling and you're trying to print it on your printer, you can actually view your model in the software and see if your model requires supports. If not, then it's really good. As a precautionary measure, we always add these rafts to it, and in case you have something which is being printed in air, um, the supports then come to your rescue. The other thing is not checking your slicer settings. Now, it could happen that you forgot to check your fan speed settings, and this is the result of what could happen. So, if you're printing something overnight, and if you forgot to check on the settings in the morning when you come, this is what you get. But if you had checked properly your slicer settings, you would get a really good model. So make sure that whenever you are printing something, you check for your slicer settings. The first thing you need to do is check for your slicer settings. It includes these parameters, your layer height, your shell thickness, your fill density and pattern. All of this decide how fast your model is going to print and how good your model will be. Like if you want it really fast, chances are that your model might not look that good, might not be that presentable. So make sure there's this balance, there's this trade-off between the fastness, like the time for printing, and the quality of your print. Okay, so we've got two websites which are really cool for 3D models. The first one is Thingiverse. So here you can find thousands of models put out by people. You've got a dragon here. I think you can just go to the explore things. Oh, I think it's the same page. Yeah, so basically you can just explore this in a free time. Look at the models. Some of them are as a creative stuff. Some of them are utility-based things which people develop for their own homes. This is like a cable sorter. This is like a free thing. It's a creative thing which has been done here. The second one is Cults 3D. Even this has really cool 3D models. We go to tools. Okay, and here you can see people have designed and printed different things for their day-to-day utilities. Okay, so this was all about understanding the technicalities of 3D printing and the technical details of the 3D printer. If you've got any doubts, we can have them right now. Okay, and also I'll show you a few things that we've printed here at the lab. In the meantime, if you have any questions, please go.
So right now, no doubts.
So, just out of curiosity, I wanted to ask a thing. Sir, all the builders that in the cases they have the basic structure of their projects.
Okay.
This is made up of 3D printing only, na? I want to.
You're talking about buildings and construction, right?
3D printing, it is.
Are
Yes,
you
sir.
talking about
Basically, after. Yes, sir. The construction, the contract or the builders after
Right.
finalizing their project.
It depends. I have seen very few of them actually, print something using 3D printers. Most of them go for the cardboard-based or thermocol-based models because that's easier to develop and showcase. 3D printing may you have small parts and it might take more time. Wherein this can the cardboard-based thing can really fill up the time required.
Okay, sir.
But yeah, there's no hard and fast rule that you can't do a 3D print. There are a few contractors who do such 3D printing models also for display. Yeah. Anyone else?
So what machines do we have? Like, do we have SLA technology also in the lab?
No, in the lab we do not have SLA. It's actually expensive. Those machines are actually expensive, and even the resin material which comes, it's around 4 times the cost of a normal FDM machine. So
we have only fused deposition.
Yeah, we only have FDM machines right now.
Okay.
Yeah, but we've got around 4 of them. So after this session, if you guys want to, after the modeling session, if you guys ever want to develop something and you want it printed, you can send in your files. We'll be happy to print and give it to you all.
Yes, sir.
Okay, so I'll show you an example. I'll show you what we've printed here at the lab. Can you see this Batman bust model here?
Yeah.
Yes,
Yeah,
sir.
so this was printed using our
Yes, sir.
3D printer. I think it's the background which is causing some interference, but I think you get the idea. It's really fine. If you can see the back, it's really come out good. I think I'll just have to the camera issue. Okay. Can you see this small machine? Can you see this?
Yes, sir.
Yes, sir.
So We actually, one of the innovators here at the lab, she designed a machine for making bowls out of leaves. And her machine is really bulky. Like you need at least 4 people to, bring it upstairs. So whenever she has to present it to people outside, she takes this small machine. She takes this small model because it's easier to carry and it can, it's got all the functionalities that, like it's got all the major functionalities that her machine has. So this is what we are expecting from you guys when you're developing solutions. If you've got like a really bulky design in mind, you can convert it into something really small, which could fit in the palm of your hands, and you can present it to people. And it also has the functionalities which you want to showcase. I think everyone gets the idea here.
Yes, sir.
And this is also something like this is a reptile that we printed. Like we did not model this, but we had to buy these models, and we printed these on our machines. So you can see the level of finesse that 3D printers can give. This literally looks like uh, a real reptile if we had it in different colors. Also, the filaments come in multiple colors, and they're like 500 grams to 1 kg spools, and you get multicolor spools as well as shiny spools. So if you're trying to develop a solution which requires multicolors, it is also possible using 3D printing. So let's suppose one part of your machine is red in color, the other one is gray in color. You can use the same machine to print using both those colors. So multicolor printing is also possible using 3D printing. Any other doubts? Because after this, we'll be moving on to the 3D modeling part. I think
No, sir.
no doubts. Okay. Is everyone on the system right now, or are you all using your phones as well?
I'm on my laptop.
Okay. Are most of you all on your laptop, or because if most of you all were on your laptop, we could have done like a simultaneous modeling session here for the 3D models.
I think we can do that. Like, just in case if someone is not on their laptop, it'll take like 1 minute to log in from the laptop.
Yeah, so you guys could take like 5 minutes for people who are not.
Yeah.
And if you have that software, it's really good. But if you don't, then you can leave it for now because the downloading will take some time, at least 15 to 20 minutes. So for people who don't have it on the systems, it's okay. But for people who have it and are not in front of the systems, please take your time. Like I'll give you all 2 minutes. We could then start with. So I have actually 3 things to be modeled here. The first one is a Lego brick. So in the Lego brick, I'll teach you what 2D sketching is, how do you extrude, and how do you make a shell or like make hollow objects. So we'll go through those things in the Lego brick. The second one is we'll be designing, not exactly designing, but we'll be using a reference image to, make a bottle. Like reference image using that to make a bottle. And the third one, if time permits, we'll be developing a rubber stamp. So all of these are like really simple things, but all the basics of Fusion 360 will be covered in these three objects. And maybe if we happen to finish this fast, you guys can then try it out on your own. It would have been best if you guys were also doing along, but I leave that up to you guys. Any doubts that you have, you can stop me in between and clarify it then and there.
Yes, sir.
Is my screen visible? Is the Fusion 360 software screen visible?
Yes, sir.
Yes, sir.
Okay, so I think we can start. So the first one is the Lego brick project. So here we start with creating a new project. So I'll just name this we4tech new.
Sir?
Yeah.
Hello, sir?
Yes,
Sir,
yes.
can we use different software for 3D modeling?
Yeah, no issues as long as you can generate STL files in that.
Yeah, sir, like Blender, can we use that?
No problem, no problem. See, the ultimate goal is if you want us to print that for you, we'll require a format which is readable to the machine. Right now we use STL files. We could also use some other files which can be converted. So as long as your softwares give compatible output, it's okay.
Is it like the software which is going to convert the slicer, which output that it will be follow?
It's mostly X3G code.
Okay, sir.
X3G is something that we use extensively. Like our machines support X3G. So just check if your software can give that output.
Yeah, can be used with 3D printer. Yes.
Yes, yes.
Thank
Okay,
you.
so yeah, welcome. Okay, so now we've created we4tech new. I'll just go in and create one folder. I'll name this Lego brick. Okay, so now we've created the folder in which we'll be uploading this file. So I think I'll also save this. Okay, I'll go to we4tech. Okay, I think I did not name it. Okay, it's okay. But yeah, this will be saved in that folder. Now, this is the basic toolbar that you have. And most of the times you're going to be using the solid portion of these tools to develop our models. Okay, one thing before everyone starts with Fusion 360 is you can go to your account, go to your preferences, and make sure that it's all on restore default. So I think if I just change this, make sure you come back to restore defaults so that there's no confusion when you guys are using it. And go down to the display settings, go to visual style, and make sure it's shaded with visible edges only. Even that is selected. So this will make sure that all your surfaces and all your edges are visible. Okay, so we'll start. Now that we're, designing a Lego brick, Lego bricks are really small and they're measured in millimeters. So you can here in your document
Excuse me,
settings.
sir.
Yes, yes.
So actually I downloaded it, but now it is telling me to create a team or something like that. Do we have to do that in Fusion
Create a
360 Subtractive?
team. No, I never faced such a thing. Has anyone else faced a team issue? Like
Yes, sir.
if
One
you,
of my
Just
teammate
written
also faced
team
this sort
name.
of issue.
Yeah,
I've
team
just
name
written
and
the
all.
team name and it is working properly. Like fine.
okay, so the person who just said that is working from them, please help your peers in the MS Team channel. Maybe you could post it there. Okay, so we'll come back. So like I said, the measurement unit is going to be mm. So you just need to check this. Initially, it can sometimes be set to inches, but then you need to change it to millimeter. So for us, it's already done. The next thing is you're going to go to assemble and click on new component. Now, every object that you design in Fusion 360, you can call it a new component because when you design a new component, it gives you the ability to, copy that item over and over again. You can merge them with other components. So whenever you are designing something in Fusion 360, go for the new component thing. I'll just label this as Lego_1. Okay, now we'll go to sketch. So this is the sketch part here. I want to create a sketch, and these are the different axes on which it is available. So I'll click this one. You could choose any of these, but I think from a visual point of view, this one is more easy to understand. So I'll click on this face, and you see that it now flattens, or the view changes for you, so that it's easier for you to sketch. Now we'll take a 2-point rectangle. Now these are some of the commonly used things, but if you go to create, there are different kinds of things. So for a rectangle, here it's only 2-point, but it could also be a 3-point thing or a center rectangle. So depending on what your preference is and how you want to develop your model, you can go for anything. But here I'll go for a 2-point rectangle. I'll place the first point at the center. And here you see, if I, scroll around, the measurements are changing. So I'll just click this to be 15.8 mm. And I'll click on tab. So tab will actually lock that measurement. And the second one is going to be 31.8. I think I should have done the other way, but it's okay. Okay, so here we have the basic layout for a Lego brick. Now what we want is Lego bricks are actually 3-dimensional. Now this is a 2D sketch. If you don't want the measurements, you can just click on them and delete them. Okay, so now what you want is you want to add depth to your 2D sketch. So what you'll do is you will go to finish sketch and you'll come to extrude. Now extrude is something that will pull up your model from the 2D sketch that you've drawn. So you click on this. It's already come on this surface because this is the only one which is available, and you'll put 9.6 mm. So now if you see, there's a model which has been created, and it's like the first step towards the Lego brick. Okay, now you want to create those small circles on top which fit onto other pieces. So what you'll do is you'll go to create again, and you'll go to you will go to sketch. You will select the surface because it's on top. You will select the surface. You'll go to a circle. You can create like a direct circle also. This one. Now you can zoom in and you can place your circle somewhere around here. And it's a 5 mm circle. So you say 5 and it sets here. Now what you want to do is you want to set this at a distance of 3.9 mm from the edges. So what you'll do is you'll click D. You'll click, like you'll press D on your keyboard. You'll press at the center. I'll just zoom in, and you'll press here. So you see this is approximately 3.8. You'll just place this here, but you'll say 3.9. You see it's shifted. We'll do the same thing for this point as well. Select here. Okay, it's also 3.8. Even here you'll say 3.9. Now if you see, this has been placed equidistant from both the edges. It's 3.9. I'll just remove these. I think I'll just okay, so we'll come here and this is much easier to see. Now that we've created circles, we'll extrude this. So extrusion is going to be 3.9 mm. So I'll finish the sketch. I'll go back to extrude. I'll click on the surface because this is the one which I want to extrude. I'll click on this and you see this has already, like, it's pointing upwards. So all I have to do is type 3.9 and it's extruded. So this is, if you see, this is kind of the basic structure. Now what you want to do is you want to repeat this, like copy this whole pattern over here. So I go to create, and under create, there is something called as pattern. And under pattern, there is regular pattern. I click on regular pattern. It says object select. So I'll select this and even this. So I want the whole, I want this whole thing to be, copied. Now I'm selecting the direction. So the direction is going to be this axis, it has to come along this axis, right? So I'll click here. Now the total distance, so what I need is I need 4 of these, and the total distance within which it should fit is 24 mm. So you see 4 of these are created. Now I also want them in this direction, so I'll just pull this out. You can pull this out here. I don't want 3, I want 2, and the distance within which all of these should fit is 8 mm. Now if I click OK, you see that the basic layout for the Lego brick is created here. Now Lego bricks are actually hollow from the bottom, so I'll just go down here. Now there's something called as shell option. Now if you look at shell, you can see that shell actually removes the insides of your model, and it will make it hollow for you. So you select this layer because this is something that you want to go in. So you select this face and you can select the thickness. So it depends. I think here it's 1.9 mm. Okay, that's good. It's come out pretty good. Okay, so this is the basic design. But inside also you have those small, circles which fit on top of these circles, right? They go in these circles. So you need to again sketch those circles and extrude them, like they'll come out in this direction. So you can go here, you can select this. And first, I think you should go with a line. What we need is reference points here. We don't have reference points. So the center of this is going to be the starting point for a circle. So you can then select the circle. So this is the point where, so that the triangle appears and it tells you that this is the center. So I keep this at the center, and this distance is 6.314. So this is the radius for this one. And we also need one more inner circle, which is 5.314. So now you've got the structure which goes inside. the top parts. Now we have to extrude these. So I'll just, okay. So now we can finish the sketch. And we'll go to extrude. We'll select only this part. So you can see that, you can select the whole layer. You can select the inside of this, or you can select this one. And that extrudes to 8 mm. So I click here and you see this has also been created. Now we want 3 of these. So we'll go back to create pattern, rectangular pattern. We'll select this whole body and we'll select the distance. So this is the direction in which it comes. I'll select 3 of them and the distance is going to be 16, like it should fit within 16 mm. And here you've got your first 3D Lego brick. Now, if you want to, these edges are going to be sharp. So there's something called as fillet. You can find it here. It's in modify. You can select this surface. Oh, sorry. Go back to fillet. Select only the top surfaces because those are the sharper ones. Select all of these. And here what you can do is you can specify the the curvature that you need for these things. I think 0.2 mm thing would be really good. And now if you see, these surfaces are curved rather than being sharp. These surfaces are curved. And I think we can again save this. So let's use the save. Okay. Okay, so we're done with the first modeling. Anyone has any doubts, or if you guys want, you can take some time to do it on your own. I'll take doubts in the meanwhile then.
Is that okay to leave the corner sharp, or whether we need to do the fillet on the corners also, like the corners of the body?
Sorry, could you repeat your question?
Uh, if we need to do the fillet on the corner of the body, like edges,
Yeah,
it also sharp now.
Yeah, it completely depends on you. If you want, you can even fillet these surfaces and decide how much your roundness would be around them. So it all depends on your use case. Most Legos I don't think have like rounded edges, but maybe for these they are rounded because it's easier than to fit in other pieces.
Okay. Just 10%.
Yeah. Any other doubts? Also, could I get a count of how many people have Fusion 360 right now? Because only then it would be. Okay, I see 5 of them right now. Okay. Okay. A few of you, like a good number of you, actually have it. So okay, take 10 minutes. The rest can take like a quick break. You guys can try this out. If you've got any doubts, I'm here. Because if you because right now I've taught you, if you do it once, it'll stay in your memory. So you can take 10 minutes to design this. Are you guys trying it out, or should we move on to the next object? And the ones who raise their hands. Are you guys trying it out?
So we can go ahead.
Okay then, yeah. Let's just go on to the next one then. So the next one is a soft drink bottle that we'll be designing
Sir?
from a reference. Yeah.
So sorry to interrupt, but one of my teammates is also facing the same problem. Like it's showing option for creating a team or join existing team.
In Fusion 360.
Yeah.
Did you guys follow the prerequisites or the guidelines thing that is there in the MS Teams channel?
Yes, actually I did follow the prerequisites. Maybe the problem is I joined through my Wellinker's mail ID. Could that be a problem?
No, even I did using my work email ID only.
Yeah, I followed the whole prerequisites, and then when I went there and I downloaded, then
Mhm.
now it is asking me whether I can create a new team or I can join an existing team.
Just click on create a new team and write the name and just go with the flow. You will land up properly.
Acha, okay, understood.
I think the problem is solved for the other person as well.
So once the extrude is done, now if I want to change anything, how do I edit it? Or how do I edit the sketch also? If I want to change the dimension.
Okay, so at the bottom of the screen, here you see there are different. My screen is still visible, right? So here in the bottom panel, you can see your sketches or the extrusion that you've done. So if you go back, there you can change your dimensions. Was it helpful?
Yeah, got it. Thank you.
Okay. Okay, so we'll just take 2 more minutes because some of you are trying it out. We'll move on to the next one now.
Yes, sir.
Okay, so when I say for the soft drink bottle, we're going to do it from a reference image. Now, when I say reference image, you can use that image to draw points over it and then build a 3D model from it. So the first thing that we are going to do is we need to download it. I'll just put this in the chat section. So this is, I've put the link in the chat section. You can download your reference image from here for the bottle. I already have it downloaded. So the first thing as usual is to go to assemble and create a new component. I'll just name this bottle. The next thing is you go to insert. Now, because this is something from your own system, you'll have to take it out. You go to canvas. Now you go to insert from your computer. It's actually named beer bottle PNG. And you can select a face on which you want to place it. So I'll take this one because the vertical one would be easier for visualization. So I click here, and here you see this is your bottle size. Now the problem here is this is really small, and I could actually scale it like this, which I shouldn't have done, because then it changes the aspect ratio. We'll just go back and. But I think you get my point. Like scaling it from here is going to be problematic because you might end up with a different bottle size altogether. You want to keep the aspect ratio as it is. So what you will do is you'll have to calibrate this image. So you click on bottle, you click on canvases. If you select this, okay, I'll just place this here first. Now I'll go to canvases, and now here I've got the beer bottle PNG. I'll right click and I'll click on calibrate. Now when I click on calibrate, I have to select 2 points here, which I'm going to resize. So I'll just click here, like the lowest point, and I'll come back. Oopsie. I'll come back up here and I'll click at this point. So here you see there's the dimensions. Here it's 68. We need to set it to 240 mm. Like typically a bottle is somewhere around 24 centimeters. So now we've got the exact reference image for the bottle that we're trying to build. Now what you'll do is, so this concept is about revolving a certain plane. So what we'll do is we'll build a sketch of this layout, this part. We'll build a sketch and then we'll revolve it around so that, there's this complete bottle which is formed. So for that, you can again go to sketch, you select this face, you take this line, you select the first point. So you're trying to make a enclosure out of this space. So I'll click here. I'll go down to this point. Now I'll come here. I'll keep this to 30 mm. And okay, so I'll have to again line. Come here. And this I'll keep to around 134 mm. So I think till here it's pretty simple and straightforward. Now if you see here, these shapes are something which cannot be covered by lines easily. So for that, what we can do is you can go back to create and you've got something called a point. And when you click on point, what it does is you can place points on these surfaces or like wherever you want on the reference image. So I'll click one point over here, one over here, one around this curve, one here. So just placing points where you feel are important for your structure. You can maybe directly place it here, one place it here, and one then maybe directly on the grid. So we've placed these points. Now we need to, connect all these. And to connect these, we have something called as spline. Now, spline is fit point spline we'll have to do, because we're going to fit a line between these points. So I'll select the first point, I'll come to the second, and like this, I'll just keep on connecting. And if you see, these points are like, you can see that the curves on the bottle are being fit because we've tried to fit points around that. Some points might not actually, resemble the actual bottle, but you can do this. Now, once you're done with the last point on the spline, what you have to do is you have to come back to this green mark here and click here. Now, what you get is, now you can, so for anything that you do on Fusion 360, pressing escape takes you out of it. So I'll press escape and it'll come out of whatever like a circle or a rectangle is doing. So your go-to thing is going to be escape. Now, here what you can do is, if you want, you can change the curvature which has already been given. So let's suppose for this point I want to change the curvature. I can use this tool. So now if you see, the curvature has gone in, and I think this is perfect. Maybe for this also I could try something. Yeah, but when I change one, the other one changes. But I think you get the idea of trying to work around with these curves, around these curves. Okay, so now that we've done this, we need to complete this, this profile plane which is there. So we'll go back to line again. I'll select this and I'll just close this. So now if you see, there's this blue colored section which has come, this one, and this is what we wanted. So now we'll just finish the sketch, and here you've something called as revolve. Now you'll go to revolve, and you see this has been already selected because this was the only closed plane available here. The profile has been selected. Now you need to select the axis, and the axis here is going to be this y-axis for us. I'm just going to click on select, and I'll select this. And here you can select the angle, or if it's also possible here. And now that I click on OK, you've got a simple bottle which has been created using a reference image. Now there are some technicalities to this as well. You could use Fillet to smoothen the bottle edges. So I'll just click here. I think I'll do this 5 mm. So now it's not that sharp. We can also make it hollow, or like a shell, because right now this is a complete body, like there's material inside as well. So you need to remove that material as well. So we're going to bodies, we're going to select the body, and we're going to go to shell, because shell is something that creates hollow bodies. Now the inner thickness that we want is 3 mm. Now I'm going to click on OK. It might not show up here because we can't see the insides, but there is something called as section analysis in inspect. I'll go to section analysis. I'll click on this plane, and here you can see that the inside of the bottle has been removed, and it's now a hollow bottle for us to use. This is pretty much the basic of creating a bottle from scratch using a reference image. We've learned here the technique of revolving around an axis. You could try out multiple things, like you could make maybe a profile of a semicircle and just revolve it around to create a complete sphere. So all of that is possible using the revolve thing. Also, for your use cases, let's suppose you found a really cool model online, you can click a section image of it, use that as a reference like we used for this bottle, and build on top of it. Like you don't have to build it from scratch. You can just use a reference image and build around it. So maybe you could use some sketching method here to, this is a bottle. I don't think what more can you can do with a bottle. Maybe you could add a, a bottle holder here, like a cup holder that you have. So you could try out that with your use cases as well. For your solutions, you could use some reference images and then use them to create your own solutions or improve on those solutions. Are there any doubts regarding this? Anyone? I think, yeah, it's self-explanatory, but you'll only have doubts when you'll try it out yourself. That is why I asked you guys to have it handy so that you could try it out. But no issues, you could try it out later, and then we have the query section, queries channel, where you can drop your questions. Yeah, I think someone was about to say something. Sorry. Okay, no one?
No one, sir. So we'll try it. Then.
Okay, are you guys trying it now? Like I can give you like maybe 5 minutes to just, take the reference image, paste it on your screen, and maybe, calibrate it. Totally up to you guys. We'll take a 5-minute breather here. Okay, we'll finish off the last one early, and then I think you guys can also then leave early if you guys have no doubts. So I'll just begin with the last model for the day. Okay, this one is pretty simple, but this one involves using SVG files. Those are image files, a different kind of image file. So you can use SVG files in your model to get something printed on it. So here, since it's a rubber stamp, you already know what kind of SVG we are going to take. It's a text image, and we're going to use it as the thing to be printed or like stamped using a rubber stamp. So we'll begin with the usual. The first step being assemble new component, and I'll name this rubber stamp. Okay. We'll go to creating a sketch, because the first thing for any sketch is going to be creating a 2D sketch. Unless you do it, unless you make a 2D sketch of something, you cannot, extrude it to make a 3D thing out of it. So I'll select this plane, and we'll begin with a line. So we'll place the first point here, and we'll keep this to be 35 mm. Rubber stamps usually are kind of a trapezoid when you view them from an angle. So the distance is going to be 5 mm, but the angle is going to be 70 degrees. Oh, I think it's in the opposite direction. Yeah, here it's 70. So I've placed this here. The same thing will happen over here. I place a line over here, 5 mm. Okay. The angle is going to be 70. We just remove these measurements because we don't require them. We'll complete this profile by connecting these two dots. And the basic structure for the rubber stamp is ready. We'll finish the sketch. Now the next thing is to extrude and give it depth, or like bring it in the third dimension. So we'll click on extrude. We'll select this plane because that is something we want to bring out. And the distance is going to be 90 mm, or like we want it to be. View from here. Here it is. This is the first part of your rubber stamp. Now on top of this layer will the SVG file, or the alphabets, or like the letters which are going to be stamped, are going to come. So for that, we're going to pick up an SVG file. So it's the same thing. You go to insert, you go to insert SVG. It's on my system, and here I have the SVG file. I'll select this as the sketch plane, and if you see here, it's come out outside this thing. So here, if you see, there's this rotation tool which is already available. All I have to do is place it at this. Now it's along the y-axis, so I'll have to change the y distance to, let's say, -30. It's come inside. I'll just keep this to -32. Okay, I think it's almost like equal on both sides. I think it's 32.5. Yeah, this looks good to me. And once this is done, I'll click enter or OK, and we'll finish the sketch. So now if you see, Oh, actually, I had to invert this, so I'll just do it again. So I'll go to insert, because when you're stamping something, it's actually the opposite. Like it looks mirrored, so we'll have to mirror that as well. So there's this horizontal swap which was there, which I completely missed. Okay, so we'll go back to this again. We'll keep this at 90. We'll keep this at minus 32.5. Come back here, and this is the horizontal flip thing which is there. So if I click on this, now if you imagine, stamping it from the other side, it'll be stamped properly. So we click on OK. We finish the sketch, and this is the top layer. So when I'm going to print this, stamp this out, it's going to come properly. But I need to extrude all of these outside. Like I need to bring them all up. So for that, we'll go to extrude, and we'll select the surfaces that we want to come out of the surface. So one of them is this. I think I'll have to zoom in. This one, this one. Okay, we'll keep this to 2 mm. Let's keep this 2 mm. So it's slightly raised. And here it is. This is your basic rubber stamp structure. You can view it from different angles. For doing that, there's this orbit tool over here. You can click here and view it in different angles. And you've also got the pan thing, which is like you can move it around. But if you're using a mouse, the center button is something for panning, and shift plus center is something for the orbit thing. So two shortcuts that you can remember is the mouse center button and shift plus mouse center button. Okay, now that we have the bottom structure, we want to create the the part where we hold the rubber stamp, and this is the surface where you want your handle to come. So what we're going to do is we'll create a line here for reference. Okay. We'll take this line, we'll place it here, and we'll place this here. Now we'll take the center point of the circle. So I select a circle here and I'll search where the triangle comes. Okay, it comes here. So I'll go for 17 mm. I'll delete these lines because these are not required. Okay, so now we have the first reference point for our handle. But I'll finish the sketch also. But one of the things about Fusion 360 is it does not let you print in air. So you'll have to create another layer on which you can print the second circle. So once I'm done with this, I think you'll get a better idea of what I'm saying. But you need to first create a separate offset plane for it. So you go to construct, and there's the offset plane. Now you select which plane do you want to offset it from. So for us, it is going to be the bottom plane. So I'll select this, and I'll select a distance of 60 mm from this plane. So you see here, this is where the second handle circle is going to be placed. So I click, so I entered 60 mm and I click OK. Now we're going to sketch again. and the sketch is going to come on this plane. So I'll click here, and we'll come back to the circle. We'll select the center. This one is going to be 30. And okay, so now you can see here, we've got the first circle and the second circle. Now we're going to create a loft. It's something called as a loft. You select loft, you select the first screen or the first circle, and you click on the second circle, and it creates a surface between them, which is solid from inside. Now that you're done, you can click on OK, and this is your basic rubber stamp. Now there are some models wherein you can make a rubber stamp with a removable stamping, like the initials which have to be stamped. You can remove them and place them. It's slightly complex than the simpler one, but just to get the hang of how to use Fusion 360 and how simple products can be created, we'll just be going with this one. I'll give you references to the channel that I followed for this one. That guy has got around 30 days of material for learning Fusion 360. They're not big videos. They're like, I think 20 minutes, 20-minute videos. So during this week, whenever you've got time, one person can, go through all those videos and try to master Fusion 360 as much as they can. I'm not saying you should go through all the 30 videos, but you could go through a few of them which help you in developing a prototype for your case studies. I think we're done with the 3D modeling session, and I think most of you guys have also understood the technicalities of the 3D printer that I explained earlier. Is there anything else that you guys would like to know, like about the solution or about the problem statements that you already have? We'll just keep the floor open for anyone. If you have doubts about this model also, you can ask me now, or maybe you can switch to your problem statements. Have you guys already started working or like have finalized on your problem statements? I think
No, sir, not yet.
Okay, have you all gone through it?
Actually, not exactly, but till
Okay.
when we have to select, or what is the ahead procedure?
Okay, so today in some time we'll be circulating a track submission form to the team leaders. You guys have time till 12 tomorrow to decide which problem statement you guys are going to work on, and then you guys can start working on it. Anything else? Okay, you've got no doubts about your submissions or the problem statements. Have you gone through it at least?
No, sir. Actually, we will go through after this class.
Okay, no problem, no problem. So I'll give you a gist. Okay, I think we can discuss the problem statements till then.
Yes, sir. So what is the reference that you were telling about, the YouTube videos?
Oh, sorry. Yeah, I'll just post the link in the chat section so that you guys can.
Thanks a lot. Thanks a lot.
Excuse me, sir.
Yeah, please go ahead.
What is the relation with 3D modeling for this problem statements? Like I am unable to relate to it.
Sorry, could you come again?
I have just read the problem statements and I am unable to relate the problem statement with the 3D modeling.
Okay, so I'll just share my screen. Before that, I'll just share the YouTube reference links that I was talking about. Just give me a second. Okay, so I've posted the reference link. This guy has got a really good playlist of 3D modeling videos. Like he's designing a lot of different stuff each day, and you guys can go through them. I've used those videos for reference because his explanation was really good, and the things that we wanted to cover here were actually covered in his videos. So I've used those same ones. Okay, now coming back to the question of okay, I'll just share my screen. Okay, so is my screen visible? Are the tracks visible?
Yes, sir. Yes, sir.
Okay, so the first one says security personnel generally have to stand for long hours, which could affect their health, spine and back, legs. Design a solution to help them take short rest breaks without having to bring things around much. Have you seen those, chair pants kind of thing, wherein you just have to at the click
Yes, sir.
of yeah. So what we're looking at is you need to maybe you can talk to a few security guards in near your places. You can ask them what kind of problems they face. Do they have chairs? If not, how do they manage standing for so long? So based on all the data that you collect from such people, you can design something for them, like something which is similar to the chair pants that I just told you. At the click of a hinge, like you just move a hinge or something, and those pants turn into, like, those are external pants, but they turn into a chair for you. So things like these, we want you to actually model them, develop a complete solution around them. Now, if you come to the second one, people in India prefer not to wear helmets. Now, that is something which I think even you guys must be facing. So we want you to develop a complete solution around it. It could be, let's say, it is because of the material that people use inside helmets, which causes irritation, or you could use. So my friends tell me that one of the major reasons for hair fall while wearing helmets is because of the heat. So it traps heat, and that kind of damages your hair follicles. So we don't want you to limit yourselves to just 3D modeling. These problem statements, some parts of them might require 3D modeling, but the idea is you develop an all-round solution around it. Now, if you come to A4, which is people with Alzheimer's tend to have memory loss. Now, if you were to design or model something like, let's say, a medicine dispenser for them, just having a medicine dispenser for people with Alzheimer's is of no use, because they might even forget to, look at that medicine dispenser. You might have to look at a app solution for it. Now, we're not telling you to develop an app. We're only telling you to give us a solution on how you can do that using an app. You could use app screens, or you could draw it on pen and paper and give it to us. It's okay, but what we want from you guys is an all-round solution around these problem statements. I think this one is really interesting. The last one, omelette making pans are round, but breads come in square shapes. So your omelets are always hanging out from your breads. So can you design something around that? Like it could be a square pan. It could be like uh, a square mold in between which goes down on pressing, and then once you press it again it comes up, so it's like a multi-purpose pan, something like this. So I'm not saying you should, because I'm saying you have to do this only, but you can come up with your own unique solutions. And if you're comfortable using softwares like Fusion 360 or SketchUp or Blender, you can design and model those and then send it to us, because that adds more value to your solution than just having it on paper. But it's okay. Learning all of these can be really complex, and you've got other things also to do. So we're not forcing you to develop a model on these softwares, but it would be good if you guys can do it, because I think each team at least has 3 members. If one of them takes the onus of working on the model and the rest work on, let's say, the business case, or if you were to make this into a profitable startup, how you do it. So all of these things can be divided among your team members. Yeah, I've been talking a lot. You guys have anything? Any other doubts?
Sir,
You guys have been
so may
pretty
I?
silent. Yeah, please go ahead.
Yes, sir. I was asking like we have to show like animation also, like how this model is going to work, or we have to write it down in form of presentation.
It's okay. So your final submission in the general channel on MS Teams, there's a prerequisite and guidelines thing. So in the guidelines for submission, you have to submit a presentation as well. We don't expect you to come with animations, because that is going to be really tough. I'm not saying you guys can't do it. Some of you already have experience, so it's completely okay if you, and it will be really good if you can come up with animations, but it's not mandatory. It all depends on your level of experience. We're not going to handicap you because the other team has come up with the animation and you guys have not. It all depends on how unique and novel your solution is going to be. Also, we're going to award points based on your primary research, because secondary research तो सब लोग कर लेंगे, like इंटरनेट पे जाएंगे, solutions देख लेंगे, उससे अपना solution derive करेंगे. But if you've got primary research to back why you're doing this, then it is going to be really great. So that is why I
So
said,
like,
sorry, go ahead.
yeah, you got no problem.
Okay, so your query solved, right?
Sir, I was asking like what kind of primary research? Can you please define a bit more?
Okay, so let's say in the tracks, there's this problem for the elderly community. चलने के लिए walking stick यूज करते हैं, but अगर हायर ग्राउंड एक्सेस करना है तो स्टूल्स यूज करेंगे या फिर ऐसी कुछ चीजें यूज करेंगे जिससे उन लोग डिसबैलेंस हो सकते हैं. So can you design something like that? Now you yourself can't be in their place and try to say okay, these guys might be facing these problems. If you can go to such people, have a questionnaire kind of thing. You've asked 10 people who are above 60, who have problems walking and moving around in the house, and you can get us those answers to back up your solution. That'll be really great. So basically, talking to stakeholders, that's what we're talking about. Here, the stakeholders are like really, maybe for Alzheimer's, you might not get stakeholders, but maybe if you've got doctors in your circle who can help you out with this, even that is primary research for us.
Thank you, sir.
Okay. Anything else? You guys are really quiet. Was this boring? Like, I know for the first time it might be boring, but did I bore you guys? Be honest.
No, sir, it wasn't.
No, sir,
Yeah,
it
I think
wasn't
there was
boring.
one or two people saying it.
Yeah, it was a bit confusing because it is so new to us.
Right. And that is the reason why, I asked if you guys were doing it along with me, because then it would have been easier and you could have asked me questions then and there. But we're going to upload all of these on YouTube, all these tutorials. You can even go watch other tutorials for other tracks. So it's not hard and fast that you have to, like, because you are in the session, you have to follow this track only. If you find some other tracks which are interesting and your team wishes to switch, we look into that as well, because we don't want to restrict you guys to just one track. The other three tracks are also amazing. Depending on how much time you have, you can watch their tutorials and decide.
Okay, sir.
Yeah, I think okay, sir, is the most I've heard from all of you guys. Okay, so it's 8:25. It's almost time. We were planning to do this till 8:30, but we are ahead of time. Any more questions on the tracks or anything else? Otherwise, if there are none, we'll pack up.
So if we have more doubts while practicing, so whom should we contact?
So did you guys get the schedule for the next 3-4 days?
No, sir.
No, sir.
Okay, you haven't got the
No,
schedule.
sir.
Okay. So you can post your queries in the MS Team thing, and whenever possible, like, I'll be there to help you out. We could arrange.
Because it's all.
Sorry, your voice is breaking. Okay, I think. Am I audible to everyone, or is it just me?
Yes.
So you are audible
Yes.
to us.
Okay,
It
so
was my bad
yeah,
network.
you were saying something.
Actually, I got disconnected. That's why.
Oh, no problem, no problem. Yeah, so I saying I'll be there throughout your competition. You can post your queries in the queries channel, and whenever possible, we'll have this meeting for doubt resolutions. And also, if you need any help with the problem formulation, like the solution formulation, um, all members from the Redx team are available for you guys. So your go-to thing is going to be the queries channel, and then from there we can take it ahead as meetings or one-to-one calls.
So what time will be our next meeting tomorrow?
So tomorrow we're not keeping a meeting because we want you guys to ponder over the problem statement. The next session is going to be on 19th, 5 p.m. onwards. So I think it will last, depending on your lectures, we might extend it till 8:30. So for people whose lectures are over early, we can start by 5. For the ones who have lectures till late, we can go until 8:30. So anytime between 5 to 8:30 on 19th. Okay, anything else, or should we log off? I think you guys haven't got time to go through the problem statements and decide with your teams, right?
Yes, sir. Actually, we had lectures throughout the day till 5 p.m.
Okay.
That's why.
Yeah, understood. Yeah, so you guys take your time. कल 12 बजे तक का टाइम है, तो if you want, we could also try to extend it. If if you guys as a team cannot, coordinate, so we might just extend it. But sit with your team and decide on this.
And we started on 6:30.
Right.
So we have time till tomorrow midnight 12 to report.
These guys were saying noon, but if you guys want more time, we can talk and we can extend it. It all depends on you guys. I think individually for team leaders, we can ask them if they need more time because they are going to be a point of contact. So discuss with your team leaders and then inform us if you need more time.
Yes, sir.
Okay, sir.
Okay, anything else? It's almost time. So we log off at. Okay, I think there's nothing more, so we log off. See you on 19th if you guys are interested in this track. And if you've got any queries, please post it in the query channel. Thank you for coming, guys. Good night.
Thank you, sir.
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 Thanks, sir.